Namaste to all. I am Dr. Nikita Jain, Assistant Professor, Department of Mathematics, Mewar University. In this video, we discuss about the topic determinant. If three homogeneous linear equation a1x plus b1y plus c1z equal to 0, a2x plus b2y plus c2z equal to 0, a3x plus b3y plus c3z equal to 0, by eliminating x, y, z from above three equation, we obtain a1 bracket b2 c3 minus b3 c2 bracket close minus b1 bracket a2 c3 minus a3 c2 bracket close plus c1 bracket a2 b3 minus a3 b2 bracket close equal to 0. So if we solve linear equation, that means if we find x, y, z in any linear system of equation, then we use the determinate method. And what is the notation of a determinate? So only two straight line and all element right in between two straight line. Here this is the notation of this determinate. So coefficient in determinate, we write coefficient of x, y, z. So in this equations, coefficient of x is a1 a2 a3, so write in first column a1 a2 a3, and coefficient of y is b1 b2 b3, so write in second column b1 b2 b3, and coefficient of z c1 c2 c3, write in third column c1 c2 c3. If we find this determinant, then a1, then we write first a1 and delete first column and first row. Remaining element is b2 c2 b3 c3, so we write in determinate form also minus b1. Next we delete first row and second column, and then we find a2 a3. Then we write a2 a3, c2 c3, we write c2 c3 plus c1. We delete the first row, third column. Remaining element write in a2 b2 a3 b3. So this is the 3 cross 3 determinate. That means this is a determinate of order 3. That means 3 row and 3 column. So we have only determinate, we find square matrix. So if we find any determinate, so necessary condition is the matrix is square. Here matrix is 3 cross 3. That means 3 row and 3 column. So we find determinate of 3 cross 3. Next, we discuss the topic properties of determinate. So first property, the value of the determinate remain unchanged if the row and column are interchanged. That means if any row and columns are interchanged but value of the determinate are not changed. Second, if any two row or columns of a determinate be interchanged, any two row of determinate be interchanged, the determinate is unaltered in numerical value but changed in sign only. That means if any two row or two column interchanged, then answer will be same but only sign changed. Third property is if a determinate has two row identical, then its value is 0. That means any two row or any two column are same, the value of the determinate is 0. Fourth property is if all the elements of any row or column be multiplied by the same number, then the value of the determinate is multiplied by that number. That means if any row we multiply 3, then answer also we multiply by 3. So next property, fifth property, if each element of any row or column can be expressed as a sum of two terms, then determinate can be expressed as the sum of the determinates. For example, a1 plus x, a2, a3, b1 plus y, b2, b3, c1 plus z, c2, c3 equal to a1, a2, a3, b1, b2, b3, c1, c2, c3 plus x, a2, a3, y, b2, b3, z, c2, c3. Next, sixth property, the value of a determinate is not third by adding to the elements of row or column the same multiplies of the corresponding elements of a row or columns. Yes, next seventh property. It should be noted that while applying operation on determinant, then at least one row or columns must remain unchanged or maximum number of operations is equal to order of determinant minus 1. Yes, next eighth property, it should be noted that if the row or column which is changed by multiplied and non-zero number, then the determinant will be divided by that number. Yes, next, how to find determinant of each of the following matrix. Yes, so first I explained already what is the difference between matrix and determinant. So matrix is only arrangement of a number, and determinant we find particular answer of these matrix. Okay, so determinant is find only scalar value and solve any determinant, but condition is any square matrix we solve. Okay, so here first example is 2 cross 2 square matrix, that means row is 2 and column is 2. So we find this matrix, first this symbol square bracket changed in straight line. Okay, so 2 minus 3 2 6 is here. So if we find the determinant of this matrix, so we multiply, cross multiply, that means 2 multiply 6, 2 multiply 6 is 12, and minus 2 multiply minus 3 is minus 6. So minus already here, so minus minus plus 6, so 12 plus 6 is 18. Okay, next solve the following determinant. This is the example of 3 cross 3 determinant. So how to solve? First we make this determinant in by 2 cross 2. So how to make? First 3 corresponding to first row. So 3 delete 3, we write 3 and delete this row and this column. 2 5 minus 3 minus 4. So we 2 cross 2, this matrix convert 2 cross 2. So we multiply 2 into minus 4 minus 8 minus 5 into minus 3 minus 15. So already minus, so minus minus plus 15. Okay, next minus 1, delete the first row and second column, then cross multiply, then we get minus 8 minus 5 plus 1 and delete first row and third column. So we find and we cross multiply, then we find minus 6 minus 2 and solve this calculation, we get the answer is 49. Okay. Yes, next minor and cofactor. So minor of any element, if we take the element of the determinant and delete the row and column containing that element, the determinant left is called the minor of that element. It is denoted by Mij. So this is the minor of any matrix M11, M12, M13, M21, M22, M23, M31, M32, M33. And if we find any minor, let us example, if we find minor of M11, that means we delete first row, first column, and rest of the element is M22, M23, M32, M33, right, and find the determinant of this. So this is the minor of any matrix. Yes, next cofactor. So cofactor denoted by Cij and is defined as minus 1 to the power I plus j times the minor of the element. It is denoted by Cij. Cij is equal to minus 1 to the power I plus j Mij. And consider this determinant, and if we find cofactor of C11, so 1 plus 1 2. Okay, 2 is a even number, so minus 1 to the power even is positive, and M11 we write first row and first column delete and we write this is a minor. So this is a cofactor of any matrix. Thanks.